Okay, so our starter today on Monday, February 8th is how do I determine the mole relationship between compounds in a formula? Let me get my pen going. So remember we learned that coefficients, and I apologize for my rough writing. It's been a while since I've written with a mouse. So it's the coefficients this is tough. It's the coefficients that determine the mole relationship between the compounds in a formula. So what is the mole ratio between aluminum oxide and oxygen? 2 to 3. What is the mole relationship between aluminum and oxygen? Again, it's a 4 to 3. What is the mole relationship between aluminum oxide and aluminum? It will be a 2 to 4 ratio or relationship. Okay, stoichiometry. Stoichiometry is the study of the number of particles, grams, or liters used or produced during a reaction. Stoichiometry extends on what we've already done. Balanced chemical equations. We've already learned how to do mole conversions. We've already learned mole ratios. So all of that put together is stoichiometry. Stoichiometry shows the relationship, this is the word you're going to fill in, the relationship between the amounts of reactants and products in a chemical equation. This is what allows us to convert from an amount of one substance to another. This is the whole purpose behind stoichiometry. And remember, stoichiometry mole ratios are from the coefficients in the balanced equations. That's what we just did in our starter. Okay? So let me switch screens. So stoichiometry shows the relationship between the amounts of reactants and products in a chemical equation. This is what enables us to convert from an amount of one substance to another. And we said this is the purpose behind stoichiometry. Now what I'd like you to do is I'd like you to write 1 mole equals blank liters. 1 mole equals blank representative particles. 1 mole equals blank grams. Okay? And you're going to write page number blank in my notes. So find those in your notes and write that page number down. Okay? So we know that 1 mole equals 22.4 liters. 1 mole equals 6.2 times 10 to the 23rd representative particles, and 1 mole equals the molar mass in grams, and that's on the periodic table. Okay? All right, so now what I'd like you to do is draw that mole map. Notice it says you must memorize. We must memorize this. So we must memorize that. We must know the purpose of stoichiometry. So we're going to draw the mole map. So I want you to draw the mole map, and yours needs to look exactly like mine. Okay? So basic information of stoichiometry. How many steps in your setup is determined by the starting and ending points. Remember, the purpose of stoichiometry is to convert from an amount of one substance to another. Now we can compare apples to oranges because we made them moles. The most common is going to be your 3 steps, and that's what I use to set up your labs. Whoops, where am I? So we have a mass or a volume, converting to mass or volume. So this would be like a mass or volume of hydrogen gas produces a mass or volume of water. These are 3 steps. Mass to moles, or the other way around, moles to mass, is a 2-step. Moles to moles is a 1-step, and that's what we're going to start with. The 3 steps of stoichiometry are get to moles, and we'll use the mole map for that. This is the mole map, so get to moles. We're going to have the mole ratio, and the mole ratio we know comes from the coefficients, and it's always the unknown over the given, and our units are always moles. And then we're going to get to our unknown, and this is our mole map. Okay? So we're get to moles, mole ratio, and get to unknown. This is my mole map. This is my unknown over given. I'm going to write that up here. Unknown over given. Coefficients are our numbers, moles are our unit, and get to unknown will be our mole map. And these are the 3 steps of stoichiometry. The mole ratio is the only time where you can have moles on top and moles on bottom. You get the values for the moles and the mole ratio from the coefficients and the balanced chemical equations. From the balanced coefficients. If you're not at the mole ratio, we said if you're not at the mole ratio, you should get your values from the mole map. And we're always going to write the given and unknown above the correct compound in the formula. So, let's start. If the reaction begins with 13.0 moles of aluminum oxide, we always underline our given. How many moles of aluminum will be made? Circle your unknown and write the given and the unknown above the correct compound. So we're going to write 13.0 moles and question mark or X moles of aluminum above it. Okay, we underline our given, circle our unknown, always start by writing the given. 13.0 moles of aluminum oxide. Okay, our first step would be get to moles, but I'm already at moles, so I can skip that first step, already at moles. My second step is my mole ratio, which is unknown over given. Oh, I have to be careful not to go into that next formula. Okay, the words on the top are the words on the bottom. So mole of aluminum oxide, which is our given, is going to be that compared to moles of my unknown, which is aluminum. Then we're going to get these numbers from 2 for aluminum oxide and 4 for aluminum. Then our third step is get to the unknown. My unknown is moles. I'm at moles of aluminum. Those cancel, and we're just going to do our math. Okay? Clear. Whoops. We're going to multiply 13 times 4. 13 times 4 equals 52. Divided by 2 times nothing is 2, which is going to give me 26.0 or 2.60 times 10 to the first moles of aluminum. Okay? All right. Ladies and gentlemen, make sure that you multiply across, give me a number. That way we don't have to worry about order of operation. Now, some of my students are excellent in math, and you want to go ahead and reduce that fraction. As long as you know what you're doing, you are more than welcome to do so. If I'm going too fast, please stop the video. If the reaction ends with 28.0 moles of oxygen, how many moles of aluminum oxide did you begin with? So, we're going to write question mark moles and 28.0 moles as my given of oxygen. Make sure you underline, circle, and label. We'll eventually get to 7 givens, so we need to make sure we keep up with our stuff. We always start by writing the given, 28.0 moles of O2. Remember, every blank needs a number, a unit, and a formula. So the first step is to get to moles. I'm already at moles, so I'm good. The second step is my mole ratio. So let's write that down. Mole ratio, unknown over given. Okay. The words on the top are the words on the bottom. Moles of O2. Okay. And our unknown is going to be moles of aluminum oxide. All right. We go to our coefficients. So aluminum oxide is 2 and oxygen is 3. The third step is going to be get to my unknown. My unknown is moles, so I don't have a third step. Now I can just calculate it. I type in 28 times 2, which is 56, divided by 3, and I get 18.7 or 1.87 times 10 to the first moles of Al2O3. Final answer. Okay, we're going to end up using this number on the next problem. Okay. So the next problem says, how many moles of aluminum did you also end with? So we got to have a starting point. Let's use 18.7 moles of aluminum oxide. And we're going to look for question mark moles of aluminum. We always start by writing the given. 18.7 moles of aluminum oxide. Our first step for stoichiometry is to start with moles, and I'm already at moles. Okay. My second step is mole ratio. Okay. And the words on the top are the words on the bottom, so we're going to have moles of Al2O3, which is my given, and we know our mole ratio is U over G. So our unknown is moles of aluminum. Looking at our numbers, we have 4 moles of aluminum for every 2 moles of aluminum oxide. Okay, some of us can reduce that fraction, some of us cannot. So I'm going to do it. 18.7 times 4 is going to be 74.80 divided by 2. And we're going to get 37.4 or 3.74 times 10 to the first moles of aluminum. And that's my answer. Okay, I'm going to stop here where we started a 2-step problem, and I'm going to do that on the next video. We did get through 2-step problems on Monday, February 8th.